Right. Good afternoon, online. So we want to take a look at integration today, right? So I just want to kind of refresh you on some of the rules that you should have an idea about when it comes to integration, right? Right. So if you look here, these are some of the rules that you should know for integration. Right. So I want to take a look at it and we're going to practice. We're going to practice a lot of these, right? I shall get this later on, right? So in integration, remember, it's reverse differentiation, right? So generally in integration, we add and we divide. While in multiplication, differentiation, we subtract and we multiply, right? Right. So these are some basic rules that we need to remember about integration, right? And generally how to integrate, right? So if I give you an integral, right? Before we start to integrate, we need to remember these small rules here, right? Wait, this thing not working. So before we start to integrate, you need to remember this. If you have a constant in front of a function like this, you could pull the constant in front. Okay. If you have the integral of a sum or you're subtracting two functions, you could simply integrate them separately. Right? If you have a b and a, you have limits. Well, you need to remember that if you have, if you have limits, you integrate and then you plug in b and a. Okay? And then you have some rules later on, I'll show you, right? One of the rules here that I want to realize, that I want to look at here, is that if you were to integrate, right, between b and a, right, that is the same as type this bad, right? That's wrong, right? That's the same as the integral between a and b with a minus sign in front. Okay, I'll fix that for you before the crash course, right? Right, so integral between a and b. So if you integrate between two limits, let's say the integral between 4 and 3, but you come and change it now and find the integral between 3 and 4, all you have to do is put a negative sign in front. That's okay? There's some small rules for you to remember, right? All right. So how do we integrate? Right, I'm going to do something code just now. I want to kind of run over it quickly. How do we integrate? If you have to integrate x to the power n, you add 1 to the power, divide by the new power, and you include your plus c. That's okay? If you have to integrate ax plus b to the power of n, you add 1 to the power, divide by this new power, and also divide by the differential of ax plus b, which is a. Right? There's a slight problem. When n is minus 1, this will not work, right? Integral of sine, the integral of sine minus cos, the integral of cos is sine. The integral of sec squared tan x, the integral of cos squared minus cot, right? This is a really nice rule that you could use to integrate sine nx cos x, right? And I will show you a technique that you could also use to get that answer. It's called integration by substitution, right? It's a technique that you could use to get this answer. Okay, I'll show you this now. Right, and last one, well, last few here, you have to learn all these integrals, right? All right, just do me a favor now. You can screenshot or you can write it down. If you want to write it down fast. Hello? Hello? Right, so these are the rules that we need to know it for integration. Right, these are the general rules, right? But you want to be able to apply it now, right? So these are all your general rules. The book I had a long time ago, I now find it. Nice book. Right, we get some basic examples here. Oh yeah, you could just do that, take up the picture right here. You could do that too. Yeah. So all right, that's all. Message. Who? Ready? Here are the right all. Let's write the first 5 or 6. The others we can work out, right? Write the first 1, 2, 3, 4, 5, 6, 7. First 7. Right? All the others we can work out. So we're going to do all this integration, then some application, right? Finish. Right, so that's a sign supposed to finish, right? It's gone. It is gone. Okay, so let's start the integration process, right? So first thing first. So let's see if we can integrate well basic things. 5x to the power of 4 minus 3x squared plus 4x dx, right? How do we integrate that? Real simple. Actually, try it fast. Quick as you will. Quick. Integrate that fast. Right, integrate that quick there. All right, so you should have that, right? So that will be 5x to the power of 5 over 5 minus 3x cubed over 3 plus 4x squared over 2 plus 3. Right? This is x to the power 5 minus x cubed plus 2x squared plus 3. Nice and easy, right? Suppose we had to integrate something like this now. 2x plus 1 all to the power of 4. How do we integrate things like this? What should I do again? Huh? Oh, before, anyway, you wouldn't really affect it. I will start back again. Right? Add 1 to the power. Yeah, that's a 1. Add 1 to the power. So you'll get 2x plus 1. Divide by that new power and divide by what? The differential of the bracket. The differential of 2x plus 1 is 2. Right? Plus 2. So you'll end up with 1 over 10 by 2x plus 1 to the power of 5. Right? Try this next one here. You know, I must give it one with a square root. Integrate the square root. Integrate 4 by the square root of 2x plus 1. Integrate that fast. Right? Integrate. Was I saying that, Ver? Integrate the bracket and differentiate. All right, Ver. Good. Good job, Ver. are there still empty face to face? Yeah. People now starting to register. The real plenty is base. About 4 people and 5 people. I think. I know, I don't really watch this. How to sign up? What? Just read the form now, Vera. Read the form I sent in the group. In the group, I sent a form. Just read the form and it have instructions on it. No, I can't send it over. I don't have any more. Right, so in integration is very, very similar to what you would have done in Form 5, right? The only thing that's really new is something called differential equations. That's a little bit new. Okay? That's when you have dy ds and just solve it. It's called a differential equation. You may have done in your project. I don't know. We'll do for yesterday. What topic? Differentiation. This thing disconnect now. Whatever we are, don't need that for things. I'll pass it once solve it. But I get it. So this is 4 by the integral of 2x plus 1 to the power of a half dot dx. Okay? And then you integrate it, leave the 4 on the outside. 2x plus 1, add 1 to the power, you'll get 3 on 2. Divide by that new power and divide by the differential of 2. Bracket, sorry. So you'll get 2. So you'll get 4 by 2x plus 1. What's this here? All cubed square root of that. Right? 3 on 2 means you can cube it and all cubed and then square root the whole thing. That's okay? Right? Sorry. And these 2 cancel here all over 3. So your final answer is 4 over 3 by the square root of 2x plus 1 cubed plus c. Right? Yeah, you have to learn to simplify your answer as far as possible, right? Okay. So a quick little practice on those. How you would handle something like this? If you had to integrate 5x cubed minus 4x squared all over x to the power of 5. How you would integrate something like that? Well, if you get this one right, I will send you back the form. How you would integrate something like the quotient rule? Bring it on top. Now, I don't like the answer. No form. Any ideas? What we can do? Saskia, ignore this, sir. It keeps disconnected. The Wi-Fi gives trouble. Yeah. Somebody online trying to talk, but the speaker here not connected. Yeah. What to do? China, and then what you would do with it? Okay, you multiply that after. So what about breaking it up? What about putting 5x cubed over x to the 5 minus 4x squared over x to the 5? Like it would? Yeah? Right? If you bring it up, you'll get minus 5 and then you multiply it, you should get something similar. Right? So what we really integrating here? Putting the 5 outside, I don't want to work with that. Cube minus 5, so that'll be minus 2. That's okay? Minus 4 by the integral of x to the minus 3. That's okay? So I'll simplify because there is no quotient rule for integration. So I have to do some simplification, right? This divided by this and this divided. Right. So I'll get something like this here. So this will be equal to 5, right? I can work this out one time. Add 1 to the power, I'll get -1 divided by the new power. And here, same thing. Add 1 to the power, you'll get -2 divided by -2 plus c. So your answer will be -5 over x plus, so cancel, and I'll get 2 over x squared. Copy it down. Any questions there? Questions? So you simplify it out, right? All right, so you remember how to simplify these things, right? Sometimes if you can't simplify it, you'll be able to use something called integration by substitution, right? I'll do it in a little while, right? All right, so that's the easy set. Let's do our trigs fast. Right, let me just run over this, how to do our trigs. Oh, wait, sorry. I want to show you one more. How are we going to integrate something like this? How are we going to integrate something like this here? So what's the answer for 4? This here. There's the final answer, right? I remove the minus sign, right? So it's 5 by 1 on x and 2 on x squared. Right? There's the final answer for 4 here. Right. How we integrated in number 5? Saskia, we have a little problem here. What's the problem? What's the problem? When you add 1 to the power, what you get? 0. And if you divide by 0, it'll become undefined, right? So in a case like this, there's a rule that we have to do, right? The integral of 1 on x is something called ln x, right? So generally, here's the rule. I wouldn't give it too much of this because you wouldn't see this plenty except for differential equations, right? If you have f of x here, and you recognize that the numerator is the differential of the denominator, if you differentiate this and again this, then your answer will be ln f of x modulus, because you can't find a lot of a negative number, right? That's okay. For example, what do you think will be the integral of x squared plus 1 to x on top? What do you think will be the integral of that? It will be ln of, very good, ln of the modulus of x squared plus 1 plus c. Now, so once the numerator is the differential of the denominator, you use ln. That's okay. Technically, none is syllabus because it's unit 2. But if you look at plenty of the differential equations, you have to know this, right? In order to integrate them. Okay. So it is there somehow. So we had to be able to do it. Try this here. X squared. Let me make it hurt your brain a little bit. Now you put 4x. What's the integral of that? What do you think is the integral of 4x over x squared? I'm only giving you one of that, right? Or 2. I'll give you one more. How are we doing that? What do you think is the integral of 4x over x squared? How is the screen looking on you? Taking off this, it's looking real blurry. Real blurry. Right, it might be a Wi-Fi. How is screen looking? Anybody else have it real extremely blurry? Because I find my data not even working good. It's clear, yes, based on your Wi-Fi earlier. Because my yeah, it's working good here. The LAN connection, the direct connection working, but the Wi-Fi giving trouble. So if your Wi-Fi home giving trouble, it might be in the same position. Right, yeah. So how are we doing this here? Right, there are two ways you can do this, right? You can simplify x and the x squared if you want, or here's what you could do. What's the differential of x squared? The differential of x squared is 2x, right? So really and truly, this would have been perfect if I had 2x alone here. Correct? But I have 4x. So can I factor out of 2? Yeah. Yeah. So I could factor out of 2, right? And then I'll be left with what? 2 ln x squared plus. Correct? Yeah. Last one. Let me bring you some tricks here. Try that fast. Let's bring in a little tricks. What's the integral of that? What shall I got for this one here? Right? What's the differential of sine? Cos. So you're done. So the answer is ln sine x. That's it. Okay. Easy, right? Yeah. Yeah, Andy. Easy. All right. Next one is yours. Number 4. Let's change it up now. Right. So just pay attention to the father's star by this, because you're going to need this when we do different equations, right? You're going to need this, right? Especially this one. Okay, especially this. These two here. Right? You need to be able to integrate that. All right, now how do we integrate sine 2x? Right? I'm gonna give you a quick refresher. To integrate sine 2x, we will get the integral of sine is minus cos, right? And it's 1 over the differential of 2x, which is 2 by 2x plus 2. Right? Watch it again. The integral of sine is minus cos, and then 1 over the differential of 2x, which is 1 on 2. Then I write back the 2x. That's okay. Try this one here. What's the integral of 4 cos 6x? Integrate that, please. What's the integral of 4 cos 6x? Follow with me online. I know it's hard to kind of type these answers, but you're okay there. Annalise Harris. You okay there? Brittany? Keelan, all okay? All right, nice. Right, junior crash course, this is one of the sections I'll spend a little more time on, right? So all the y'all seeing 2 long classes or 3 long classes, well, extra long class on the last week. Right? I'll give you a quick answer. Because I want to do plenty past papers on this, right? Because you're not going to revise this again until a month later. Ready? So the first thing you do, you pull the 4 on the outside, then you integrate, right? That's okay? Pull the 4 on the outside, then you integrate. So you'll end up with 4 by the integral cos is sine 1 over the differential of 6x with 6, right? And then you write back 6x plus 3. Okay? 4 over 6, that's 2/3 sine 6x plus 3. Okay? Saskia, you okay with that? Shabara? Okay, nice. Next one is yours. I want to give you one here. How do we integrate cos squared x? Let's start easy, right? How do we integrate something like this? How would you integrate cos squared x? Any ideas? When you see questions that not in this form, you have to find an identity that could take it from here to here. Right? There's an identity that'll take it from here to here. So we're going to use cos 2x is equal to 2 cos squared x minus 1. Right? And we can make cos squared the subject of the formula. Cos squared x is equal to cos 2x plus 1 carried by the 2, a half by everything. The reader will have there. All right. Right. So you have to remember these identities, right? To move from here to here. Yeah, Shabara. Remember this? Next one is yours. Let me show you remember. Right? So how do we integrate it? Well, we write this here. We replace cos squared x with this. So I'm going to put the half on the outside and you'll integrate cos 2x plus 1 dot dx. That's okay? So that'll be equal to half the integral of cos 2x is 1 over 2 sine 2x, and the integral of 1 is x plus 2. Okay? Copy down. Then I'll make you hurt your brain a little bit and try this next one here. Where is oh, nice. Good. I want to focus on integration by substitution. That's what you'll see a lot, right? Any questions online? I'm going to give you one. You'll have to remember the trig identity, right? Right? You'll have to remember the trig identity. Pupanaya, you okay there? Shucks. At the mark, there's a room. You good? All right. So I'll give you one here for you to try that, Pupanaya, between you and Shabara. You have to remember your identity, right? I'll make it easier. I won't give you sine squared. Right? And all the examples are gear away, so they probably can't remember sine squared. So I'll give you about cos squared, but here's what I want. Here's what I would like. I would like 5 cos squared 5x. I want you to integrate that. Try and integrate that for me. Actually, for some limits. That's a good idea, Andy. That's a good idea, Andy. So when they work it out, those who online can message and answer. I like how you're thinking, Andy. Let's put pi on 2 and pi on 4. Right? Huh? Calculus. The calculus and a calculator. Right? Try that there for me. Try number 7. How you getting cos squared 5x? We talked about that already. Right? I showed you how to go from. Actually, I should make it a nicer number. Hold on, let me make it a nicer number. Let me just make it a nicer number, right? 5 means you want to get a fraction on it. Where did I put my marker? Right? Forget the 5, right? Put it as 6. That'll be easier for you to multiply. Otherwise, you get too much fractions. Right? So I showed you. Actually, I could leave 5 because I squared here. Anyway, leave 6, leave 6. I'll stop in there. Right. I showed you what to do when the angle changes. Anybody remember? If cos squared x is equal to half cos 2x plus 1, what would be cos squared 6x? What should you do? Anybody? Multiply not the entire thing, the angle, right? Multiply the angle by 6. That's okay? So if this becomes 6, you multiply the angle by 6. So this will now become what? 12. And that's it. Oh wait, Shivani finished already. Shivani, how are you? Oh, see what you do. No. So you're not multiplying the half. The half stay the same. Right? Only multiplying the angles. So if here is 6, this becomes 12. Okay? Try that fast. The angles will not change. Okay? Sorry, the lengths, the other values will not change. Only the angles will change. Oh yeah, work it out and put in the limits. Let's see what you get. You take a calculator. You get We get the 6. All right, so what you'll get here, pull the 6 on the outside, you'll get the integral between pi on 2 and pi on 4 of a half by cos 12x is multiplying the angle by 6 plus 1 dot dx. Okay, so you can pull the half on the outside one time, so 6 by a half is 3, and we're going to integrate between pi on 2 and pi on 4. We're going to integrate this, right? The integral of oh wait, no, sorry. So the integral of cos 12x is 1 over 12 sine 12x. The integral of 1 is x. Right? Nice. So you can pull out this 3 on 12 and then plug in pi on 2 and then plug in pi on 4. It may not look nice, but right, so you have 2 by pi on 2 minus, sorry, plus pi on 2 minus minus sine 2 by pi on 4 plus pi on 4. And then final answer. What's your final answer there? You'll have 3 pi on 4. Anybody get that? 3 pi on 4. Oh, sure. This should be 12. That should be 12. I'm going to write 12. Plug it in, see what you get. Right, somebody have 3 pi on 2. So could you go it over again? Yeah, I'll go it over again. That's now. In fact, let me do it one time. Right? Cos squared, look back here, right? Cos squared x is equal to half sine 2x. So it means that cos squared 6x, that's what they asked us for up there. Cos squared 6x is equal to half by, multiply the angle by 6, multiply the angle here by 6. Right? So cos squared 6x is a half cos 12x plus 1. So I did that here. I take out the 6 and I replaced cos squared 6x with 1/2 cos 12x plus 1. Right? And then I factor out the half, then I start to integrate. The integral of cos 12x is 1 on 12 sine 12x. The integral of 1 is x. Right? And then I plug in pi on 2, and I plug in pi on 4, and I'm trying to work it out. That's okay? Zachary? How much will I get? What I get, Kyle? Pi over 4. Any other answers, Olia? Again, plenty different answers. Anybody get pi over 4? I have 3 pi over 4, I have 3 pi over 2, and I have pi over 4. Any more? Yeah, I'll go the most popular. In fact, they're none popular. I just plug those in the calculator now. What you got here? So this is what? Pi on 6. This is sine 6 pi, which is probably 0. This probably 0. Minus 3 pi. Yeah, 3 pi is probably 0 as well. Yeah, that's 0. Plus pi on 4. So this is pi on 2 minus pi on 4, pi on 4. I get pi on 4 inside here. This correct? So sine 6 pi is 0. And sine 3 pi is also 0, right? Oh yeah. This is 0, this is 0. Pi on 2 minus pi on 4 is pi on 4. So 1/4 by pi on 4 is pi over 16. So we get 3 on the outside. Right here. Rana got that and Emily got that. You got that? But then it will have a 3 here too. Right? Okay. All right, Shivani. Nice. So that's the integral of trigs there. You have to remember when integrating these functions with squared and cube, you have to put them back into a form like this here, right? That's all right? You sure? Sure. All right. So sometimes you have your integrals looking like that. And then let's take a look at the most popular type for you now. Let me just get one from last year. Although I think last year was integration by substitution. I mean, yeah, before me, not last year. Wait, this is unit 2. Right. Yeah, what you got last year? Yeah, substitution. Okay, so head up integration by substitution, right? Integration by substitution. Right? Make a small note, integration by substitution is used. Integration by substitution is used when the integral is difficult to simplify. When the integral is difficult to simplify. And can only be done by making a substitution. And can only be done by making a substitution. And can only be done by making a substitution. That's okay? So sometimes you will see questions looking like this, right? We'll jump straight into an example. Any questions online there? Karina there? Karina, are you okay? Oh, wait, no. Karina is not there. Karina there. Are you okay there? Down in the back there? Zachary? Varun? All right, so good. So sometimes you're going to get questions like this. It's very difficult to simplify. So for example, if you have to integrate 2x square root of 4x squared plus 2. Right? Suppose I want you to integrate something like this. Right? We can't multiply that out. Right? So we can't really simplify that out. And there is no product rule for integration. Right? In a case like this, we need to make a substitution. Right? So if we let, sometimes they'll tell you what to substitute, sometimes you have to figure it out. Generally, is determinate bracket. Right? So the determinate bracket here will be 4x squared plus 2. So if we let u equal to the determinant bracket, so u is equal to 4x squared plus 2. Then du dx, the differential of this, I'll show you why we do know that just now, right? The differential of this 4x squared plus 2 is equal to 8x. That's okay? If I were to just drop u in here, I wouldn't be able to integrate because u is a function, x is a function, and I have dx here. But the only way I can integrate with u is everything must be in terms of u. That's okay? So u is 4x squared plus 2, du dx is 8x. So it means that I have to replace this dx here. So dx is equal to cross multiply, and you'll get du over 8x. Right? So it means that this dx here is du on 8x. Let's see what will happen now. So let's say we substitute, you'll get 2x by the square root of u, which is u to the power of a half, by du over 8x. Okay? What will happen here? What will happen here? The x will cancel. The x will cancel, and you'll get this x will cancel with this x here. And you'll end up with 2 over 8, which I can put outside here, by u to the power of a half dot du. Can I integrate this? Yes. Because it's u with respect to u. Right? So that will be 1/4. U to the half will be u to the 3 on 2 all over 3 on 2 plus c. That's okay? Put the 3 on 2, well, flip the 3 on 2 and bring it outside. You will end up with 1/4 multiplied by 2/3 by u to the 3 on 2 plus c. There's 2 will cancel here, so you'll get 1 over 6. And we know what u is, right? U is 4x squared plus 2 all to the 3 on 2 plus c. Right? See how it works? The most important thing is that when you decide what is u, which is generally what's in brackets, you differentiate and you replace dx. Right? Sometimes this will not cancel. The x won't cancel. Right? So in a case like that, you had to make x a subject and put it in here sometimes. Right? But generally, what you do, you differentiate, you substitute u, substitute dx. And you should get an integral that has u alone. It cannot have any x. Okay? Because x is a variable, u is a variable, you can't integrate that. That's okay? Yeah? Copy it down. Copy it down. I'll put in some limits in a little while, right? You can try that past you for one time. Right, I'll give it one more. Take your time and try number 2 and you finish. Try this one, right? Maybe substitution differentiated and then but you get trouble. Okay. Or in department cross. Let's no fun. That comes from, I guess, 2 by 5. Oh, but 2 by 1 on 5. 1 on 5. 1 on 5, right? All right, let's go. Right, so let u equal to 3 minus 5x squared, right? So du dx is equal to minus 10x. So dx is equal to du on minus 10x. So again, clear here? You'll see now. Thanks. So when we substitute, we'll get the integral of 25 on the outside. Actually, I can leave it right here, right? 5x by u to the power 4 dot du on minus 10x. This x will cancel with this x here. And you'll get 5 on minus 10, which is minus a half, by the integral of u to the power 4 du. So this is a half, right? U to the power of 4, that'll be u to the power of 5 on 5 plus c. A half by 1/5 is minus 1/10. Right? Try not to flip it up on thing, right? And you'll have u to the power of 5, which is 3 minus 5x squared to the power of 5 plus c. Okay with that? Shabara? Why you make a mistake? Because you're going good here. Last line. So after integrate, I just multiply 2 by the 5 and I substitute the u. That's all. Okay, let's go again. Any questions online? Let's try one a little bit different where it wouldn't cancel out. Right? So what is here? I'm just making up something, right? Let's just say we ended up with a square here. When you reach here, it will not cancel out. So you'll end up with the integral of 5x u to the power of 4 du. So everything perfect here except for this x. So what you just do is come back here and make u the subject of the formula. Actually, let's make it square. Come back right here and make x the subject of the x squared the subject of the formula. Or 5x squared, anything you want. If I make 5x squared the subject, I'll get 3 minus e. You're seeing that? So now what I can do is I can substitute this as 3 minus e. Actually, it's a good one. I should make this one up. I'll take, right? I'll take copyright on this one. It's a good one. All right? So here's what will happen. Can we multiply this out? Can you multiply this out? You'll get it 3 by u squared minus u cubed. Can we integrate this? Yeah, simple, right? So here's what will happen. Sometimes when you do this and you make the substitution, The x doesn't cancel out. So what you have to do is go back to the original substitution and make x or x squared the subject of the formula. That's okay? You have to look out for that. Sometimes that will happen. Okay? Right? And then when you make a substitution, the integral you get should be easy to work out. All right? So I'm going to give you one like this now. Actually, a past paper, right? Right, so today we focus on the integration, and then next day we focus on the applications, right? I'll focus a lot on differential equations and area. Right, let's try this one here. This is 2019, number 7, number 16. He told you what to use. Let u equal to 1 minus x. Integrate this here, please. Integrate x by 1 minus x all squared dx. Try that, please. Let's see what you got. But okay online there? Varun? You okay? Shabish, I know you good. Koi, you good? Jada? What's hard to do? No. Wait, none of the atoms here, right? That's you okay there? Cursor, she spelled cursor wrong. Nadim here. No Nadim. Oh, Israel in consequence? William here, he's the place to be. Dr. Yusuf. Hurry up, 2 minutes again. Let's see what you got. I can do it. Anybody sick? Anybody sick? Andy, you got you? Pretty much it was that. Is a matable. Hi. Yeah. Somebody become one, John, or something like that. I will like pool in somewhere. There's a pool there. All right. So let's see. U is equal to 1 minus x. So therefore, du dx is equal to -1. So dx is equal to du over -1. That's okay. Nice. But you won't see it until you substitute sometimes, right? So the integral of x by u squared du by -1. We have a problem here. We have x still, right? So we need to get rid of the x. So since u is equal, right? Since u is equal to 1 minus x, x is equal to 1 minus u. So I can take this x off and put 1 minus u. Right? I'll put the minus on the outside, right? So I'll get -1 by the integral of, take off this x, and I'll put 1 minus u. I'm taking off the x here, right? And I put in 1 minus u by u squared by du. Everything here good, so I can go ahead and integrate. Well, simplify first. U squared by 1 is u squared. U squared by minus u is minus u cubed. That's okay? Are you okay with that? Now I can integrate. So I'll end up with -1 by the integral of, sorry, I can integrate now, right? So it's -1 by u squared on, sorry, u cubed on 3 minus u to the 4 on 4 plus c later on, right? You can leave it like that or you can multiply it out. Up to you. Questions online? Right? If you have limits, you have two things you can do. So suppose I wanted to put in limits here, 2 and 1. You have two options. Actually, right? This one you might get the sign rule. But if you have limits here, Oh yeah, I was going to say something. That's why I stopped there, right? So if you watch this here, right, before I stop back in you. If I give you limits, right? There are two things you can do. Integrate, and when you get back the x, put in 2 and 1, right? But if you don't want to do that, you don't want to use 2, you don't want to have to go and substitute the values back, because that looks nice, right? What you can do is find the limits in terms of u. So these are the limits for x. You need to get the limits for u. So when x is 2, find for u. When x is 1, find for u. And now you have the limits for u that you put in there. That's okay? If ever you see one like that, right? Which I might show you in a little while. So multiply this out, and you will get minus u cubed on 3 plus u to the 4 on 4 plus c, and then plug back in u. That would be minus 1 on x cubed over 3 minus 1 on x to the 4 on 4 plus. That's okay? Let's see if we can do our next one. Last one, right? 2018. This is the most popular, right? They like to bring integration by substitution, I believe. Any questions here online? Last one, let's try 2018 quick. Right, these are worth like 6 marks, right? Again, they told you what to use. U is equal to x to the power of 4 plus 2. They would like you to integrate x to the power of 4 plus 2 all cubed by 4x to the power of 7. That's a 7, right? 4x to the power of 7 dot dx. Right? Go ahead. Integrate that fast. Okay. But yeah, hi. Yeah. Okay. Hi. Take a time with the substitution and thing, right? Right, last one are we done? I'm gonna do this now. I'll do it on Brian here. All right, let's see how this went. Let us see how this went. I'll put on my marker here. Right, so I'll start right here. And we'll let u equal to x to the fourth plus 2. So it means that du dx is equal to 4x cubed. So when you make dx the subject of the formula, you will end up with du over 4x cubed. So I'm gonna make a substitution here now. Right? So I'm gonna make a substitution. I'm going to replace this with u. So I'll get the integral of u to the power of 3 by 4x to the 7 by du over 4x cubed. Right? The 4 will cancel. The x cubed will 7 minus 3 will give you 4. So you'll get the integral of u to the power of 3 by x to the power of 4 dot du. Of course, that's not good enough because we still have x. So we know that since u is x to the 4th plus 2 right here, right? X to the 4th plus 2 right? Since u is x to the 4th plus 2, it means that x to the 4th is u minus 2. So I can make a substitution here. So we'll get the integral of u cubed by u minus 2 dot du. Okay? Multiply it out. You'll get the integral of u cubed minus 2u cubed dot du. When you integrate, you'll get u to the 4 over 4 minus 2 u to the 4 over 4 plus 2. Right? Well, I shouldn't put plus 3 because that's a different period. Oh, thanks. That's right here. So when you multiply that by that together. Thank you. And then I shouldn't put plus c here because it might be a different constant, right? But I can put it after. U is what? What was u again? Right. X squared plus 2 all to the 5. X to the power of 4 plus 2 all to the power of 5 over 5 minus 2 x to the power of 4 plus 2 over 4 all over 4. You can simplify that to 1 plus c. That's okay. Andy, double. Right? So nice and easy integration there. Yeah, thanks, Emily. Right? Yeah. So finish the integration. Being able to actually integrate, we're going to do the applications next week. Area, volume, and differential. And to find the equation of the curve. That's okay? So we'll do that next week. Focus will be differential and area. Right? Those are the two popular types. All right. All right. So nice. Any questions online?